In this lesson, we'll be drilling and tapping in 3 axes. After completing this lesson, you'll be able to create a spot drill operation and create drilling and tapping toolpaths. Let's carry on with the file from our previous example, and if you've had any trouble up to this point, you can upload the supplied dataset Multi-Axis Positioning V7. So this dataset will contain the 3 toolpaths that we've already talked about. Our adaptive that we used for roughing, our 2D contour to clean up the outside of the part, and our 2D adaptive that allowed us to pocket the top of the part, so now we can start talking about drilling and tapping. First, we're going to just take a look at drilling and tapping in 3-axis operations. So we do have multi-axis drilling that we need to do, but we want to make sure that we understand all of our options first. So when we start to talk about drilling, the first thing we need to do is select the appropriate tool. Now, as we look at our library, we want to make sure that we go into our cloud library and select tool number 1, which is our spot drill. Then we need to select hole locations. We can do this a few different ways. We can select faces, points, or a diameter range. All the holes in this file from this orientation are 0.201, which is a number 7 drill bit and a 1/4-20 tap size. So by simply setting a diameter range, it automatically grabs all 4 of those. Also note that we have a tool orientation dialog box. This allows us to change the orientation of the tool if we need to, say, come in from a different angle. Now for this operation, we're coming in from our traditional Z direction, so we don't have to worry about changing it just yet. For the heights, right now we need to make sure that we are actually just doing a spot drill to start the holes. So we don't want to use the whole bottom. We're going to use the whole top and add a small amount of offset. In this case, I'm going to go ahead and do -0.1, which will take us down and spot drill those 4 locations. Because we're not worried about drilling so much as we are just spotting the holes, we're not going to worry about doing a PEX cycle or deep drilling. But let's go ahead and take a look at this by simulating. We're going to skip ahead past our 3D adaptive, past our 2D contour, and past our 2D adaptive, and then take a look at spot drilling each of these holes. We want to ensure that we're not drilling or spotting it too large for our drill bit. Now, if we want to go a little bit past what the 0.201 is, that would be okay because it might actually help the tap start if we're using a thread cutting style tap rather than a roll tap that's going to be forming threads. Again, all these decisions need to be based on your specific geometry, your tools, your design intent. The next thing that we want to do is we want to reuse this toolpath. So I'm going to right-click on it and duplicate it. The next thing that we're going to do is edit this and start by selecting a different tool. Again, in our cloud library, we'll select tool number 2, which is our number 7 drill. Then inside of our geometry, notice all the holes are already selected. However, now we want to ensure that the bottom height is going to be our whole bottom. We've already got an offset, so if we rotate this around, you'll notice that the holes do extend past the bottom of the hole. However, at this point in time, this pocket has not been machined. So this extension is not quite enough for us to get through the bottom of the part. So what I want to do is I want to extend this a little bit more, assuming that my drill has enough clearance. So if we go down a distance of -0.25, this will allow us to come all the way down through the bottom of the part. Also notice that we have a drill tip through bottom, which will extend it a set amount based on the diameter of your tool. From here, we're going to change the drill cycle. We have chip breaking and deep drilling. Both of these will allow us to have a PEX cycle. However, chip breaking differs from deep drilling because the retracts are different. When we do a chip breaking, there's only a partial retract, which means if it goes down 1/8 of an inch, it might come back out a 1/16 before it drills again. However, deep drilling will allow the bit to come all the way back out of the hole, which helps coolant get in there and helps evacuate the chips. For this cycle, I'm going to use a partial retract and all the default settings that are based on my tool size, and then say OK. So now we've taken our original spot drilling operation and we've turned it into a PEX drilling operation. I'm going to rename drill 2 and I'm going to call this spot drill. I'm also going to rename my 2D adaptive and I'm going to rename this top pocket. And I'm going to rename my 2D contour to be outside profile. Then I want to rename my 3D adaptive toolpath to be roughing. The next thing that we want to do is we want to take our drill to operation and duplicate it. From here, we're going to edit the duplicate copy. We're going to change our tool. Again, from our cloud library, we want to go into tool number 4, our right-hand tap. Then we want to make sure that our cycle is changed to tapping. For the geometry, all the holes are still selected, but we need to ensure that the heights are correct. Remember that we are extending through the bottom of the part, exactly where we drilled. Because we don't need to go as far, I'm going to reduce this amount to be minus 0.2. And again, we need to ensure that our tool can actually go that far. Once we're happy with that, we now can rename these operations. So drill 2, I'm going to call pec drill. And then the copy of this, I'm going to call tap. So now we have our roughing operation, our outside profiling, and our top pocket, followed by our spot drill, our pec drill, and our tapping operation. So at this point, we've explored getting this file ready so that we can start to work on multi-axis toolpaths. We haven't approached the inside pocket of the part yet, but that's not something that we have to take care of at this point. We can always come back and do it again. That's one of the beauties of the multi-axis machine. We do need to make sure that we plan the operations accordingly. For example, we had to do the outside contour so that we had a nice face that was ready for us to do a spot drill, a drill, and a tap. But we couldn't do the contour until we did the outside roughing. So there is an order of operations that we still need to follow, even if we're using a multi-axis machine. But at this point, let's navigate back to a home view and save the file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.